In this session, I'll be explaining about fixed wing UAV. The parts and components of fixed wing UAV are fuselage, wing, tail assembly or empennage, payload, propulsion system, landing gear, transmitter and receiver, flight controller, electronic speed controller, battery eliminator circuit, and inertial navigation system. I will explain all these parts and components briefly in the next slides. The first component is fuselage. Fuselage is the main body of fixed-wing UAV. It provides lift and also supports the wings and tail assembly of the fixed-wing UAV. Various payloads including passengers and cargo may be stored within or attached to the fuselage exterior. The fuselage of fixed-wing UAV might vary in shape. These shapes include lifting body, blended wing body, and conventional wing. The shape, aerodynamic devices, and materials of the aircraft are all beneficial to drones' lift-to-drag ratio, stability, and control. The wings, tail assembly, and landing gear must be attached to the fuselage in such a manner that it provides stability and control for the drone operator. Some of the examples are MQ-9 Reaper, shown in figure 1, is made by General Atomics, which is a conventional wing UAV, and S-70 Kotnik B, shown in figure 2, is made by Sukhoi, which is a flying wing UAV. The wing is a lifting surface around which the air flows and generates lift. The primary wing that generates lift on an aircraft is called as main plane. The various aerodynamic devices that can be fitted to the wing include vertex generators, flaps, slats, ailerons, wingtips, spoilers, and speed breakers. Canards, which are small wings, are also fitted to the nose of an aircraft. The wing configurations include straight wings, folding wings, swept wings, delta wings, tandem wings, and variable sweep wings. The fixed-wing UAVs with different number of wings are monoplanes, biplanes, triplanes, quadruplanes, and multiplanes. The aircraft in which its entire body acts as an airfoil and has no fuselage or tail assembly are known as flying wing UAVs. Some examples include Mantis, made by BAE Systems, which is a conventional wing monoplane with swept back wing, shown in figure 1, and Bat, made by Northrop Grumman, which is a flying wing monoplane, shown in figure 2. The entire tail configuration of fixed-wing UAV includes a fin, radar, horizontal tail plane, and elevator. There are different types of tail configurations, including conventional empennage, T-tail empennage, V-tail empennage, Y-tail empennage, etc. Some examples for fixed-wing UAV with different tail configurations are Hermes 900, made by Elbit Systems, which is a conventional wing monoplane with V-tail empennage, shown in figure A. The FQM-151 Pointer, made by AeroVironment, which is a conventional wing monoplane with T-tail empennage, shown in figure B. Payload of a fixed-wing UAV includes all additional weight that the UAV can carry other than its base weight, such as cargo, passengers, and additional equipment that is not required for the aircraft to function. The payload excludes the weight of the things that are needed for the functioning of the drone, such as fuel or other power sources. The different types of payloads such as lidar, radar, gimbals, cameras, thermal imagers, etc. are used for all types of drones, not just for fixed-wing UAVs. The few payloads adapted to the fixed-wing UAV design are seed dispersal system for reforestation projects and large storage compartments which are attached to the bottom of fixed-wing UAVs used to drop water on large areas which are affected by fires. Some of the examples are the Firebird made by Northrop Grumman, which is equipped with electro-optical or infrared sensors, radars, along with other possible payloads. MQ-25 made by Boeing, which is capable of carrying large amount of fuel and acts as aerial refueling drone for other manned and unmanned aircraft. Next is the propulsion system. The propulsion system of fixed-wing UAV provides power to propel the drone. The propulsion system includes machines and devices such as engines, propellers, batteries, fuel cells, etc. The types of power plants include engines, batteries, hydrogen fuel cells, solar power, and motors. All these types of propulsion systems are used in all types of drones, not just in fixed-wing UAV. The examples are the Stalker made by Lockheed Martin, which is powered using solid oxide fuel cell with propane, which enables the drone to fly for 8 hours. The Silent Falcon made by Silent Falcon UAS Technologies and by Aerospace is powered using photovoltaic cells, which provides 12 hours flight time. Next we have is the landing gear. The landing gear of fixed-wing UAV are used for takeoff and landing from surface such as water, snow, ice, and land. The landing gears can be in the form of wheels, skis, and floats. Based on different types of landing gears, we have different types of UAVs such as unmanned seaplanes, unmanned ski planes, unmanned amphibians, and conventional drones. All these types of landing gears allow the drone to operate in various environments. Some examples are Flyox 1 made by Singular Aircraft, which is unmanned amphibian flying boat, and the second is X-56A made by Lockheed Martin, which is conventional wing drone with wheeled landing gear. Next is the transmitter and receiver. The radio transmitter and receiver of fixed-wing UAV help the operator to control the UAV and send and receive data from UAV using electromagnetic waves. These components are used for all types of drones, including fixed-wing UAV design. The drone operator controls the drone with transmitter that generates and transmits electromagnetic waves to the receiver that is placed on the UAV. The receiver then sends the received data to the UAV flight controller that responds accordingly. This helps the operator to increase the speed or change the direction of the drone during its flight. More sophisticated UAVs require large equipment called ground control stations or mobile control stations, depending on whether UAVs are moving during their operation, which extends the use of handheld controller. These large controllers may increase the range of UAV, which is useful to long-range fixed-wing drones depending on power output and quality of antennas used for data exchanges. Here are some pictures of transmitter and receiver. Examples are RQ-4B Global Hawk made by Northrop Grumman, which uses ground control station and has flight range of 22,780 kilometers. The second is Disco made by Parrot, which uses handheld remote controller and has flight range of around 2 kilometers. Next is flight controller. Fixed-wing UAV flight controller is a circuit board equipped with varying number of sensors and equipments on the drone. It contains all the information gathered by these sensors and controls the speed of the aircraft and data it measures. The flight controller is considered as the brain of the drone. These flight controllers are used for all types of drones, not just for fixed-wing design. Wires and ports, electronic speed controllers, power distribution boards, motors, inertial measurement units, barometers, and other additional equipments are all connected and controlled by the flight controller. The flight controllers may also include features such as built-in compass, current sensors, autopilot module, or else these devices need to be purchased separately. Open source flight controllers are shown on the slide. Next is electronic speed controller. The electronic speed controller of fixed-wing UAV is a device that is used to control and change the speed of electric motors. Electronic speed controllers are used for all types of drones, not just for fixed-wing design. Electronic speed controllers include microcontrollers and integrated power distribution boards. The microcontroller controls the motors and the power distribution board is a component that can either be built into each electronic speed controller or can be separately placed in between the power source and the electronic speed controller. Power distribution board distributes right amount of power to each electronic speed controller. The power distribution boards have integrated battery eliminator circuits BEC to regulate amount of voltage distribution to each electronic speed controller. Typically, each motor requires its own electronic speed controller. Innovations have 4-in-1 electronic speed controllers, which is a circuit board that contains 4 separate electronic speed controllers that work at a time, which makes it more compact and lightweight. The electronic speed controller need to be connected to the receiver so that the inputs from the operator can be implemented in the drone. Some pictures of electronic speed controllers. The battery eliminator circuit is a voltage regulator used to distribute required amount of power to any electric component that needs power, thus by eliminating the need of multiple batteries. Eliminator circuits are required to regulate DC voltage from the battery and distribute required voltage to each component such as flight controller, payloads, inertial measurement unit, IMU, etc., as different components may require different amount of power. Between power distribution boards and battery eliminator boards is that power distribution boards supply power from the battery to electronic speed controllers, but they need built-in battery eliminator circuits to regulate voltage, whereas battery eliminator circuits distribute and regulate the voltage sent from the battery for each component in a drone. Some examples of battery eliminator circuits used in fixed-wing drones are 20A Pro made by Castle Creations and 10A made by ZTW. Are some pictures of battery eliminator circuit. We have inertial navigation system. The inertial navigation system is an electronic device which consists of several sensors such as inertial measurement unit, barometers and magnetometers. The inertial navigation system measures and records the drone's specific force, angular velocity, direction, fuselage orientation, altitude and magnetic field. Are used in all types of drones, not just in fixed-wing drones. The inertial navigation system is a guidance system that enables the drone to have autopilot capabilities. The inertial measurement unit IMU is a small component inside the inertial navigation system which consists of accelerometers and gyrometers which help in collecting data such as acceleration and orientation of a drone. The measurement unit and inertial navigation system work together with global navigation satellite system sensors that are set up within artificial satellites to determine the exact location of a drone. The inertial navigation system and inertial measurement unit work together with barometers which measure the air pressure in order to determine drone's altitude. The navigation satellite system sensor fails, the data collected by inertial measurement unit IMU can be taken as primary navigation system. Some examples for inertial navigation system. Lastly, we shall see the list of fixed-wing UAVs. Summary of the course. Unmanned aircraft system consists of number of subsystems such as aircraft, payload, control station, aircraft launch subsystems, recovery subsystems, support subsystems, communication subsystems, retrieval equipment, navigation system, data links, transport subsystems, etc. Advanced unmanned aircraft performs operations and is open for use cases such as surveillance, surveying, spraying, delivery of goods, etc. The types of UAV based on size are very small, small, medium and large. UAV based on use cases such as human transportation, tackle air pollution, map fires, hazardous environments, road networking, inspect large infrastructure, supply hospitals, etc. Drones that use aeroplane-like wings, not rotors, to generate lift are known as fixed-wing UAV. Various parts and components of fixed-wing UAVs are fuselage, wing, tail, payload, propulsion system, transmitter and receiver, electronic speed controller, landing gear, battery eliminator circuit, and inertial navigation system. And at the end, we saw the list of fixed-wing UAVs. With this, I will end up this course here. Thank you.